Take a look at this map of India. To successfully defend these massive borders with both Pakistan and China simultaneously, Indian military doctrine dictates a strict requirement: 42.5 active fighter jet squadrons. But when we switch this view to a chart showing actual current numbers, a significant gap appears. The Indian Air Force currently operates just 29 squadrons. That shortfall becomes a pressing problem when we bring Pakistan onto the board. They currently field 26 squadrons. That is nearly as many as India, but with a major strategic advantage. They only have to prepare to defend a single front. Add China's Air Force to the equation, and the scale tips completely. China operates 66 squadrons, heavily dwarfing India's current capabilities. The math here is undeniable. India is outgunned on paper. Maintaining a standard pace of slowly replacing old aircraft one for one will not close this gap before a potential conflict arises. Compounding the mathematical deficit is an aging fleet. The Indian military is actively phasing out decades-old aircraft, meaning total squadron numbers are shrinking right now as legacy jets are permanently retired from service. While India's fleet size contracts, the technological ceiling of its neighbors is rising. By the end of the year, Pakistan plans to acquire fifth-generation J-35 stealth fighters directly from China. Right now, the absolute peak of India's aerial capability is capped at 4.5-generation technology, primarily represented by imported aircraft like the Rafale. Losing the numerical advantage is dangerous, but losing the technological edge at the exact same time forces a complete pivot in how the country arms itself. The planned solution is the Advanced Medium Combat Aircraft, or AMCA. This project is designed to give India a fully indigenous fifth-generation stealth fighter. This schematic demonstrates why fifth-generation tech is so difficult to engineer. Standard radar waves hit a traditional fourth-generation airframe and bounce right back, making it highly visible. A fifth-generation airframe uses highly specific geometry and chemical coatings to absorb or deflect those waves away from an enemy receiver. The stealth profile also requires hiding all missiles and bombs inside the aircraft's body. Engineering internal weapons bays that can snap open and close at supersonic speeds is a highly complex physical feat that only 3 nations in the world have successfully mastered. The obvious question is, why spend decades building this from scratch? Why not buy F-35s from America or Su-57s from Russia and close the gap immediately? Relying on foreign suppliers for proprietary software and maintenance gives external governments functional control over Indian military hardware. If a supplier halts part shipments or software updates during a crisis, those fighters become useless. For India, sovereign stealth is a matter of operational survival. To get the AMCA built, the Indian government made a highly unusual move. They assigned the 15,000 crore rupee request for proposal to a coalition of private defense and manufacturing titans, including L&T, Tata, and Bharat Forge. Historically, a massive aviation contract like this would default to Hindustan Aeronautics Limited, or HAL, the country's state-owned aerospace monopoly. Handing the reins to the private sector represents a massive disruption to standard operating procedure. This graphic shows the core reason behind that decision. HAL is currently operating with an order book roughly 8 times larger than its optimal manufacturing capacity. The state manufacturer is already heavily burdened with producing multiple squadrons of older generation fighters, like the Tejas, along with light combat helicopters. They simply lack the physical bandwidth to invent and scale a brand new stealth program. Even with private industry taking over, one major hurdle remains: jet propulsion. India does not currently possess the domestic capability to manufacture a fifth-generation engine, meaning the AMCA will still rely on components from American and French suppliers for the foreseeable future. The AMCA project forces a necessary evolution. Building a new airplane is not enough. The country has to birth an entirely new, efficient private military-industrial complex to ensure those planes actually leave the factory floor. We can track the planned execution of that massive industrial pivot on this timeline. Prototyping is scheduled for 2028. First flights are targeted for 2030, and full Air Force induction will not actually happen until the mid to late 2030s. That creates a highly precarious 10-year gap. For an entire decade, the Indian Air Force will have to hold the line against rapidly modernizing adversaries using the 4.5 generation technology they possess right now. and the finish line is moving. While India focuses its next decade on achieving fifth-generation stealth, global rivals are already testing AI-driven sixth-generation platforms. Ultimately, this highly complex technological race plays out physically across some of the most unforgiving, actively contested terrain on the planet. The success of the AMCA project rests on private industry's ability to build more than a complex airframe. It is a transition toward a self-contained defense ecosystem intended to secure Indian airspace for the rest of the century.